All right, we're looking at P3, transformations of absolute value equations. Let's jump in and let's look at number 2. Your task here is to identify a whole bunch of stuffs and graph the thing. So the first thing you're supposed to identify is going to be A, and A is your initial slope, and A is -2. And remember that, that is initial slope. For absolute value, it's always the slope because absolute value is linear. Let's think about our vertex here. Let's write our form up here. Our form is A, absolute values of x minus h plus k. Now, it's kind of weird, that just has that x there, and that's all that it has. So let's think about this. I know, and I hope that you know, that you can add or subtract 0 to anything and not change it, right? So I'm going to put that 0 there for a line-up process. So when I talk about my vertex here, my vertex is at hk. That's part of the deal. The vertex is at hk. And the h value is 0. 0 doesn't have sign, so it's just 0. And then the k value is 3. Big deal. Now, I actually have enough information now to graph this thing. This is absolute value. Absolute value looks like the V. All right, I have a vertex at 0, 3, so I don't go anywhere on the x-axis. I rise 3 units. And my initial slope is that I fall 2 and run 1. Something a lot of kids have a hard time with is that absolute value looks like a V. A lot of kids just draw a line. You have to go both ways on this. You have to go both left and right. Otherwise, you don't draw a V. And that's what that thing looks like. Now, the transformations that we have, all right, you'll notice that A is negative. We have a vertical reflection. If we think about what mom was, and that's how I know we have vertical reflection, because my little dash guy here is mom. That's the absolute value of x. If we think about what mom is, we'll notice this thing is basically twice as tall. So we do have a vertical stretch, factor of 2. And if you make a comparison to mom, you'll see that this thing has been shifted up 3 units. So we have a vertical translation. This is also called shift sometimes, often, of up 3. There you go, there's number 2, children. Well, it's not too bad. We're also supposed to talk about domain and range on this one. So this V that we have, it is running left forever and it is running right forever. Therefore, its domain would be negative infinity to positive infinity. It falls forever, but it stops at a high value of 3. Now, we always talk about the small number first when we talk about domain and range. That's what we always talk about, small number first. Forgive me, having technical difficulty on my laptop here. So my range, we talk about the small number first, is negative infinity all the way up to 3. We put a bracket on that 3 because that's a solid point on the graph and I can touch it. Now, it'd be cool if you guys got set builder notation down. Negative infinity to positive infinity, talking about x, all values of x such that x is an element of the real. You talk about negative infinity to 3 on range, we're talking about y. All values of y such that y is less than or equal to 3. It is important that you understand how to read set builder notation. It'd be really cool if you learn how to write it too. Anyways, there's number 2. Here's the one reason you don't see me do a lot of videos on this particular board, because it's time consuming. I have to erase everything. And I guess if I really wanted to get into YouTube big, I'd go back and I'd edit out where I do all this erasing and save you the boring time of doing such a thing, right? All right, let's move on. Let's see here. Oh, we got a fraction, so number 4 is going to scare you. So let's look at number 4. 4 is we're 1/2 of x plus 3 minus 5. Now, I always say a picture is worth 1,000 words, so really before I talk about transformations, I'd like to graph it. And I didn't read the instructions on here, but I'm willing to bet. No, it did not say graph mom, okay? But I'm going to graph mom too. That's a big deal that you graph mom, because you got to know what mom looks like to be able to do everything. I see plus 3 minus 5. This plus 3 literally means not right 3, but left 3. And the minus 5 means down 5. So I'm going to go left 3. I'm going to go down 5. And that is my vertex. Now you talk about your A value, which is your slope. It's 1/2. I'm going to rise 1 and run 2. Should put me about right there. To draw the V, you got to go both ways, kids. So I'm going to have to fall back 2 and rise 1 as well. And my V looks a little something like this. Now, the vertex here was left 3 down 5, so the vertex is at -3, -5. The transformations that I see is obviously that I went left 3 and down 5. That's a big one. Those are called horizontal and vertical translations. There is a horizontal translation. And it is left 3. There is a vertical translation. And it was down 5. You will notice that if you think about what mom looks like, that this thing is wider. Now, there's two ways we can talk about that. We can talk about it as a vertical compression, or we can talk about it as a horizontal stretch. We're going to stick with vertical compression. It has been vertically compressed. It has literally been pushed down, compressed, with a factor of 1/2. It's also known as scale factor. Domain for any absolute value equation is always going to be negative infinity to positive infinity. The range on this one, we got to start with this low y value. The low y value right here is -5. And then it rises on the other side of the V towards positive infinity. Let's do over our set builder here. This is all values of x as domain such that x is an element of z real. We talk about the range. Here, we're greater than or equal to -5, but smaller than infinity. So all values of y such that y is greater than or equal to -5. There you go. Done 2 of them. I think there's 9 things on this piece of paper. So let's keep going here. Page 2. All right, let's look at 5. 5 is one of these you got to be careful on. 5 is not in the correct form. Your correct form here would be A, absolute values of x minus h plus the k. You notice 5 talks about 2 x's. So what we're going to do is we're going to do a little factoring here. We're going to factor out what's called a monomial. We're going to pull, we already have a negative. We're going to pull the 2, and that's going to leave inside x minus 3 because 2 times 3 is 6, right? And then we have the plus 3, and it wasn't part of absolute value, so we didn't pull a number from it. This is what the equation actually looks like. This would mean right 3, not left 3. That's a hard pill to swallow, and this would be up 3. So when I talk about graphing this thing, my vertex is simply right 3, up 3. That's where she is. This first number you see, that's your slope, kids, but do remember that a V goes both ways, left and right. This one falls 2 and runs 1. So it looks a little something like that. Always be thinking of what mom looks like when you start talking about transformations. Mom contains the point 0, 0, 1, 1, and -1, -1. That's mom. That'll help you with your translations. Do the easy thing first here, which is A. A is actually -2. That's what A is. Get that in the right spot there. That hot pink is not showing up like it should. See what this color does. Vertex here was right 3, up 3, so the vertex is at 3, 3. And the transformations, she is upside down. We call that a vertical reflection. What else has been done? She has actually taller, even though she's opening upside down. She's steeper. Look at mom. That is going to be a vertical stretch. She has been pulled downward. Factor of 2, not -2. The negative was the vertical reflection. And of course, we have our horizontal and vertical translations. I'm just going to say shifting here to save some time. But we were shifted right, 3. And we were shifted up. It's a bad looking S there, isn't it? Shifted up 3 as well. All right, domain and range for this thing. Domain and range. Every absolute value equation has a domain of negative infinity to positive infinity. That's just the way they are, because they run left forever, they run right forever. So that's what they do. Negative infinity to positive infinity. Range, we talk about the low number first. The low number is actually negative infinity. And it rises as you move from the left to the right, all the way up to a high value of 3. That's a solid point, so we're going to put a bracket on that thing. And again, set builder notation. All values of x such that x is an element of the real. Or, over here for this guy, the deal is I'm 3 and less, right? Or all values of y, since it's range, such that y is less than or equal to 3. All right. That's the last of the graphs that I think, well, I'm going to do one more graph. And which one looks interesting? I'm going to leave 7 for you. Be careful on 7. And I guess I'll take a look. And at this point in the video, I'm just going to kind of run through it here. A is going to be the first number you see. She is negative 2/3. X plus 3, wrong spot on that negative 2/3. I see plus 3 minus 2, change sign on the first one, negative 3, keep the sign on the second one, negative 2. That's where my vertex is. It's not hard, but boy, kids want to leave that sign the same. So we're going to go left 3 and fall 2. Put me about right there. My A value is negative 2/3. I'm going to have to fall 2 and run 3. But I got to go both ways, because what am I drawing? A V. That's right. Looks a little something like that. All right, the transformations that I see here is obviously the vertical reflection. It's upside down. It's caused by that negativity. So we do have a vertical reflection. This thing is wider than mama. That's actually called a vertical compression, because if you think about something, a narrow V, and you push down on it, it gets wider. So there's a vertical compression. With a factor of 2/3. And now let's go ahead and talk about what else we have. We had a left 3 down 2. And I don't feel like writing horizontal and vertical translation, but left 3 down 2. Domain, same as it's always been. Negative infinity to positive infinity. Range on this one, we start low as we move from left to right. So negative infinity. Always encapsulate the infinity symbol with parentheses. And we rise to this high value of negative 2. And that's a solid dot. So I'm going to go ahead and keep that there with a bracket. And one more to do. BRB. All right, the last thing to do is number 9 up here. Hopefully the rest of my classes will go better today than this one went, because boy, it was kind of rough in my first period class. A line passes through the point negative 2, 1, and 3, 0. Write an equation of this line in standard form. Okay, so first things first, I'm going to use this form right here to write an equation of the line. A times x minus h plus k. I need to figure out what A is. A is my slope, okay? I'm going to work right to left, 0 minus 1, over 3 minus a negative 2. That's y minus y over x minus x gives. And I get negative 1/5. Doesn't talk about being perpendicular or anything. I'm going to go ahead and let this 3, 0 right here be my h and my k. Because it's just going to be a smaller equation because it's going to have a k value of 0. So I start substituting in. I get y equals negative 1/5 of x minus h being 3, and then plus the 0. All right, good start. I need to be in standard form, though, which is ax plus by equals c. And the issue is this is not even in slope-intercept form. So the very first thing I feel like doing is something we call the distributive property. So I'm going to distribute that negative 1/5 in. I'm going to have negative 1/5 x plus 3 times 1 is 3. 3/5. The reason I did positive is because a negative times negative is positive. And now I'm going to start making it look like this guy over here. So this piece has to go to the left. That's going to make it a positive 1/5 x plus the y, now equal to 3/5. The issue here is a is a positive integer. That is not a positive integer. That is a positive rational number. When I look at 1/5, I actually think in my head 1 divided by 5. And the fix to division is multiplication. So I'm going to distribute a 5 to all 3 pieces of the equation I've written. You know, go back old school, 5th grade math, 5's cancel. That's an x. 5 times y, 5y. Old school, 5 times 3/5. 5's cancel, 3. And that, boys and girls, is standard form of that line. All right, there you go. Over half your homework. I did 5/9 of your homework, right? So I did more. You're welcome.